Telecompany Douglas Productions and Svetlana Productions movie experiment part number 4. Sponsor of program Douglas Konzen. Helper girl, magnet girl Svetlana Konzen.
Okay, thank you, Svetlana, for that introduction. I want to show the difference between a three-phase line reactor and a three-phase transformer, and a three-phase auto transformer. Because if any of you order a three-phase transformer off of, say, eBay or somewhere, chances are it's not going to be a standard three-phase transformer. They're pretty expensive, but what you'll get is called a line reactor. So this costs like $35 here, free shipping, and it's a line reactor. And what a line reactor does, it has this top bar with spacers there, see that? And also that's some sort of insulating material like micarta or something. And here's a bigger line reactor, and you can see it right here. This goes all the way across. And here's a smaller one that hasn't been taken apart yet. And if you look close, there's a fiber, that fiber stuff right here. So an electrician friend of mine says they call these ticklers. And what they do is they filter out the spikes in three-phase systems. That distance right there works like a spark gap, and it lets the high voltage stuff go through, but not the lower voltage stuff. And probably you all know about an auto transformer by now if you watched any of my videos. And an auto transformer, you can tell it'll have a wire that connects this phase, and this phase straight across. I believe that's called a tap wire. So in this one, I cut that one wire into three small wires right here. And then I use the remaining phase wires, coil wires, to be what comes out with two wires. So that's about all I wanted to show, is the difference between a line reactor and a regular three-phase transformer, and how you can tell for sure. See that? It says three-phase reactor. It'll say three-phase reactor here too. I can focus it. There it is. See, three-phase reactor. So anyways, that is what I was playing with. Just a minute. So this was originally a three-phase line reactor too. And this bar right here is removable. And then it makes it easy, because you don't have this bar across here. You can, like what I did is I made 12 parallel winds 12 parallel wires. These are 25 gauge thick. I put 12 in parallel, then I wound from the top while this was removed, and it went pretty easy. And then I have a choice of how I want to hook up those multi-filer winds. And for instance, the primary here is all series 80, so it gives it higher impedance, so you can put in higher voltage. Well, I wanted this to be a step-down transformer, so these I have 6 in parallel connected in series to another 6 in parallel. And so when I ran this coil and they're secondary, I was getting that 16 volts or so. And then when I rectify it, it brings it down to about 15. So this was meant to run an inverter. So I need to experiment with that more too. So might as well show you. So what I did is I cut these laminates from sheet steel 22 gauge I got at Home Depot, and I varnished each side of each plate and stuck them on there like that. And the thing that's kind of original is having these skirts go down. Probably should have those thicker, and they're catching some of the flux coming out the sides. And again, this is a bit transformer, bi-toroidal transformer, and the back EMF when the secondaries are loaded is supposed to shoot here and across and back down to reinforce the opposite secondary instead of going back into the primary, as is normal. That's why this space is here, because it jumps over, bypassing the primary, the back EMF. Doesn't work all the time. So, because you have to ask yourself, why would the back EMF even want to go that way? So it needs to have like least resistance. It needs to have this coil in a half sine wave that's of opposite polarity of this half sine wave at the same time. Opposite magnetic polarity, so that the south here would actually suck the north right into itself. And my theory is you want this to enter the opposite secondary at the zero line of magnetic force, right when it's flipping from north to south, right at that time. And then it'll plunge downward with double the force. That south coming in here, but that's a whole other theory. So, okay, I'm going to let this go. Just wanted to show what line reactors are compared to three-phase. Okay, thanks for watching.
Thank you for watching. I think it's very good experiment. Have a nice day, guys, and see your comments. Thank you very much.